The US military spent billions trying to replace just one machine gun. In 40 years, within 4 different programs, 10 weapon designs have come and gone. But here's what nobody tells you. Only one challenger actually survived the gauntlet. You're about to witness 15 brutal defeats where brilliant engineering gets devoured by indecision, where bureaucratic gridlock kills innovation, and where defense contractors burn through billions fighting over a single contract. And the whole saga kicked off with one deceptively simple objective: make the M249 Saw's ammunition weigh less. But here's the twist. The M249 wasn't just defending its position, it was the reigning champion. For 40 years, wave after wave of challengers stepped into the ring, armed with plastic bullets, computer-controlled firing systems, and promises to revolutionize squad-level firepower. And the M249 crushed every single one of them, until one finally landed a hit. 2004, the Pentagon finally acknowledged what every machine gunner already knew: carrying ammunition destroys your body. A standard combat load, 600 rounds for the M249, weighed 17 pounds, just the bullets. The gun itself added another 17 pounds on top of that. 34 pounds total, before you even count body armor, water, or anything else. So engineers started asking a question that sounds almost stupid in hindsight. What if the problem isn't the gun at all? What if it's the ammunition? That question launched the Lightweight Small Arms Technologies Program, LSAT. 14 years of research, somewhere between $50 million and $80 million in funding, depending on which accounting you trust. The goal was deceptively simple: cut 40% of the weight from both the weapon and the ammunition compared to the M249 baseline. Their solution was called cased telescoped ammunition, and on paper, it looked like the future. Instead of a bullet protruding from a brass shell like conventional ammo, the bullet was completely embedded inside the propellant. The entire package was wrapped in a polymer cylinder instead of traditional brass. This wasn't just a material swap. The geometry mattered. Cylinders pack with almost zero wasted space compared to tapered cartridges. You could fit more rounds in the same volume. And the plastic casing didn't conduct heat the way brass does. In theory, ejecting a hot plastic case would pull thermal energy out of the weapon instead of leaving it to soak into the chamber walls. The gun stays cooler, the barrel lasts longer. At the same time, engineers also explored caseless ammunition concepts. No casing at all, just a solid block of propellant with the bullet bonded directly to it. But the propellant blocks were fragile. They cracked from rough handling. Moisture could penetrate and ruin an entire batch in the field. For a logistics system built on distributing millions of rounds to forward operating bases in every climate on Earth, this was a non-starter. So LSAT pushed forward with the polymer-cased design. The engineering worked, the prototypes functioned, but the LSAT ammunition was fundamentally incompatible with the M4 rifle. And by 2016, Army doctrine had shifted. The new threat wasn't insurgents in Afghanistan. It was Russian body armor, Chinese ceramic plates, near-peer adversaries. And once near-peer threats became the focus, weight savings alone weren't enough. The Army wanted a new caliber and new lethality. LSAT was solving yesterday's problem. Weight reduction doesn't matter if your rounds can't penetrate the target. So while engineers were perfecting polymer-cased ammunition in laboratories, the Saw kept doing what it had always done: delivering lead downrange with absolute reliability. First challenger defeated. The king held the throne. But gun manufacturers weren't giving up. If the Pentagon wouldn't buy experimental ammunition, maybe they'd buy a better gun that used conventional ammo. Commercial off-the-shelf designs, proven technology, no supply chain nightmares. Knight's Armament stepped up with their light machine gun, the LMG. This design traced its lineage back to Eugene Stoner's Stoner 63 mechanics, a constant recoil system where the recoil spring absorbs every bit of energy. The action floats inside the receiver and produces almost zero muzzle rise. Flat shooting. Belt-fed, lighter than most heavy-barreled rifles. Special operations units tested it extensively. It performed, but the Army never adopted it as a standard replacement. The problem wasn't performance. The problem was incremental improvement. Even though Special Operations liked it, Knight's LMG wasn't enough of a leap to justify an Army-wide procurement shift. You don't dethrone a champion with marginal gains. Second challenger down. And this is where the institutional logic gets fascinating. Instead of buying new guns, the Army poured millions into the M249 Product Improvement Program, maintaining 30-year-old receivers, replacing worn barrels, upgrading feed mechanisms. Government Accountability Office reviews documented that operating and support costs for the aging Sofleet kept climbing, consuming a massive chunk of the small arms budget. Think about that. They were spending money to keep an old weapon alive instead of replacing it. Why? Because the requirements process for a full replacement hadn't solidified around a new caliber. And more importantly, because the SAW still worked. It was heavy, it was outdated, but it was reliable. And in combat, reliability wins. The king wasn't stepping down voluntarily. Meanwhile, the Marine Corps decided to go their own direction, the Infantry Automatic Rifle Program, IAR. And this program forced a doctrinal debate worth $150 million. The question: what actually creates suppression in a firefight? Old doctrine said suppression comes from volume. The noise and impact of hundreds of rounds keeps the enemy pinned. You need a belt-fed weapon with a quick-change barrel to sustain that volume of fire without melting the gun. New doctrine said suppression comes from accuracy. If you can actually hit and kill the target with precise fire, they're suppressed. Dead men don't shoot back. So you don't need a belt-fed machine gun. You need a lightweight, magazine-fed weapon that an infantryman can actually aim. The Marines went with the new doctrine, and HK's M27 won the contract. Short-stroke gas piston, closed bolt designed for accuracy, functions like an M4, so training is minimal. Can sustain automatic fire without overheating. Magazine-fed. On paper, revolutionary. But the SAW wasn't competing in the IAR program. This was a different weight class, a different mission. Still, several serious contenders were tested for that contract, and understanding why they failed reveals something important about what it takes to challenge an established weapons system. The Ultimax 100 used a constant recoil principle. The bolt never slams into the receiver. Soldiers could fire full auto from the shoulder and keep every round on target. Lighter than the SAW, used 100-round drum magazines. The Marines rejected it. Open bolt design hurt first-shot accuracy. The controls were completely alien compared to the M16, and the drum magazines were bulky and slow to reload under fire. The Colt IAR featured a massive aluminum heatsink wrapped around the barrel. The idea was to dissipate thermal energy and extend sustained fire without needing a quick-change barrel. But Colt used a direct impingement gas system. Hot gas and carbon dump directly into the receiver to cycle the action. For a rifle, fine. For an automatic weapon firing sustained bursts, you're wearing out the receiver faster than the barrel. The gun kills itself. The SCAR Heat-Adaptive Modular Rifle, Hammer, featured a thermal regulation mechanism. The weapon would automatically switch from closed bolt to open bolt when chamber temperature hit a critical threshold. Closed bolt for accuracy when cool, open bolt for cooling when hot. Brilliant engineering. The Marines rejected it immediately. Too complex. Too many failure points for an infantry weapon. None of these challengers could dethrone the SAW because they were optimizing for the wrong problem. The SAW's strength wasn't accuracy or weight. It was that it worked everywhere, every time, for decades. You can't beat that with clever engineering alone. But the M27 adoption ignited a firestorm within the Marine Corps. General James Conway publicly questioned the entire concept. Conway expressed concerns that squad members carrying additional magazines might struggle to resupply the automatic riflemen in combat, especially at night. He argued that the M249's doctrine of fire suppression depended on the sound of continuous fire, and that a 200-round belt simply delivered more sustained firepower than 30-round magazines could match. This wasn't a technical debate. This was a philosophical war. One side argued that replacing a 200-round belt-fed gun with a 30-round magazine reduced the squad's ability to pin down the enemy. Fire superiority comes from volume. The other side argued that the M249 was so inaccurate that its 200 rounds were mostly wasted noise. The M27 allowed the gunner to actually kill targets instead of just making noise. By now, in the Marine Corps, the M27 became the standard rifle for many infantry units and supplanted the SAW in many squad roles. But it hasn't completely eliminated the SAW from service, because for certain missions, you still need sustained belt-fed fire. The King adapted. It didn't die. And this adoption wasn't cheap. Initial unit cost hovered around $3,000 with optics, later dropped to about $1,300 for the bare rifle. Congress challenged the Marines in 2018. Why give a sole source contract to a German company for such a large order without letting U.S. manufacturers like Colt or FN compete? The contract was worth $29.4 million. The Government Accountability Office upheld the decision, but nothing, absolutely nothing, compared to what came next. 2017. The Small Arms Ammunition Configuration Study concluded that standard 5.56 NATO may not penetrate modern Russian and Chinese body armor at combat ranges. The 5.56 was becoming obsolete against near-peer threats. The entire foundation of U.S. infantry firepower, the M4 rifle and the M249 SAW, both firing the same 5.56 round, might be ineffective on tomorrow's battlefield. That realization birthed the Next Generation Squad Weapon Program, NGSW, the most ambitious and expensive small arms program in U.S. military history. This was the first real threat to the SAW's throne. Not a marginal improvement, not a doctrinal shift, a complete technical leap. The Army's requirements: a new 6.8mm caliber capable of defeating level 4 body armor at 600 meters. The engineering challenge was brutal. You need to drive a heavy 6.8mm bullet fast enough to penetrate ceramic armor at range. That requires chamber pressures exceeding 80,000 psi. For context, most rifle cartridges operate around 55,000 psi. The NGSW demanded tank-like pressures in a shoulder-fired weapon. 3 companies submitted radical approaches, and each one had to solve the same problem. How do you contain 80,000 psi in a portable weapon without it exploding in the soldier's hands? Textron Systems, with all their LSAT research experience, submitted a cased, telescoped, belt-fed machine gun using 6.8mm polymer ammunition. The ammunition was light. The feeding system was a nightmare. Complex, bulky, required complex electrical systems for timing and fire control integration. The ejection path of the large polymer cases was chaotic. Hot cases flying out the side, hitting the shooter, interfering with prone firing positions. The Army found it completely unacceptable. Textron was eliminated. On paper, Textron had the most advanced ammunition technology. In practice, the weapon couldn't function in real combat conditions. The SAW's simple, proven belt feed system crushed another challenger. General Dynamics submitted the RM277, a bullpup design using true-velocity polymer-cased ammunition rated for 80,000 psi chamber pressure. The bullpup configuration kept overall length short while maximizing barrel length, impulse averaging technology to mitigate recoil. But the Army was on the fence. The bullpup action placement put the chamber explosion too close to the soldier's ear. 80,000 psi creates a pressure wave. Even with hearing protection, this was a safety concern. Reload mechanics were awkward, and critically, the design couldn't feed a belt if needed. And then there was the thermal problem. Remember the LSAT lesson? Polymer cases can reduce heat transfer to the gun body, but they also don't pull heat out of the chamber the way brass does. So depending on firing mode and bolt type, polymer can either help or worsen heat management. The M277 used a closed-bolt automatic rifle design. That trapped heat in the barrel. Without an open bolt system or a quick-change barrel, the gun would overheat faster than a metal case system that ejects heat with every spent brass casing. Another challenger eliminated. That left Sig Sauer and the XM250, the weapon that finally did what 10 other designs couldn't. Sig's innovation was the bimetallic cartridge, a stainless steel casehead locked to a brass body. The steel base handles the extreme pressure and prevents casehead rupture. The brass body expands normally to seal the chamber. This allowed Sig to use conventional manufacturing techniques and a standard machine gun action. Lower technical risk compared to exotic polymer ammunition or bullpup mechanisms. The improvements were subtle but critical. The feed tray cover opens to the side instead of flipping up. You can keep your optic mounted and zeroed while loading the gun. Small detail, massive practical advantage. Sig Sauer won the NGSW contract in April 2022. The weapons and ammunition contract is a 10-year firm fixed-price deal with a ceiling of $4.5 billion. The initial delivery order was $20.4 million. Vortex Optics won a separate contract with a ceiling of $2.7 billion for the XM157 fire control system. But here's the part nobody wants to talk about. Remember how this whole story started? 2004. 17 pounds of ammo was too heavy. The LSAT program spent $80 million trying to fix that weight problem. And now, the 6.8mm round weighs roughly 3 times more per round than .556. A standard combat load for the XM250 is 400 rounds, weighing approximately 27.1 pounds. That's over 10 pounds heavier than the ammunition problem we tried to solve 20 years ago. So soldiers carry significantly fewer rounds. We didn't solve the weight problem. We traded capacity for penetration. The SAW lets you carry 600 rounds of lighter ammunition. The XM250 forces you to carry 400 rounds of heavier ammunition that hits harder. Different gun, same compromise, just recalibrated. For the first time in 40 years, the SAW met a challenger that could actually compete on every metric: range, penetration, reliability. The King finally faced a legitimate threat. But the controversy didn't end with performance. Sig Sauer now supplies nearly everything. The newly adopted M17 and 18 service pistols, the XM250 machine gun, the XM5 rifle. That kind of consolidation creates a single point of failure. Even with backup contractors, consolidation increases risk. If SIG's production line stalls, if the company hits financial trouble, the Army's entire small arms pipeline becomes vulnerable. And here's the bigger question. After 40 years and billions of dollars spent trying to dethrone the SAW, did they actually succeed? Or did they just create a more expensive, more complex weapon that will face the same replacement cycle in another 40 years? The SAW survived polymer bullets, constant recoil systems, heat-adaptive mechanisms, and doctrinal revolutions. It survived because it worked. Simple, reliable, proven. The XM250 might be the weapon that finally kills it, or it might just be the next challenger in line, leaving us with a $4 billion question. Did we fix the weapon or just the paperwork?